third harmonic. Okay, so this is a vibrating one. So you can see here, standing waves are set up in a string when one end is connected to a vibrating plate to produce a standing wave. When the plate vibrates at one of the natural frequencies or resonance of the string, large amplitude standing wave are created. This is large amplitude. Large amplitude here. Okay, large amplitude known as antenna. Alright. Standing wave pattern in a vibrating water glass, as you can see in the figure A. The glass shattered if the amplitude of vibration becomes too great, as you can see in the figure P. A water glass shattered by the amplified sound of a human voice. Let's try example. Two waves traveling in opposite direction on a string fixed at x equal to 0. Highlight the information given. X equal to 0 produce a standing wave. Remember, standing wave described by the function y1 and y2. There are two equations because this is standing wave. 0.2 sine 2.0x minus 4.0t meter. And this one same but difference in sign only because this is opposite direction. So we have a negative and positive. First one, A. Determine the function for the standing wave. So the question asks for the function. Recall back from the slide general equation for the standing wave, which is y equal to 2a sine kx cos omega t. Right, let's have a look at the solution. For that, we proceed with B first. What is the maximum amplitude at x equal to 0.45? C, what is the maximum amplitude and where does it occur? A, okay, as I mentioned, we took this equation and substitute all the information given from the question. I substitute all in the equation. Therefore, y equal to 0.4, 2 times with 0.2, so we got 0.4 here, sine 2.0, because k is 2.0, x cos 4.0 is the omega here, time with t. Okay, so we got the wave function for standing wave. Then B, the question asks for the maximum amplitude when x equal to 0.45 meter. So we just substitute the value of x in the equation here from part A, 0.4, so 0.45 times with 2 here, so we got 0.9 cos 4.0 times with times. So then, calculate all this of the information here. So we got 0.31 for amplitude cos 4.0t. So t is not changing because for the maximum amplitude occur. So then when cosine, so when maximum amplitude is 0.4 meter, the maximum amplitude is 0. We find 3 part A. And when sine equal to 1 and cosine equal to 1. So actually maximum amplitude occurs midway between nodes. Alright. First node must start at 0 because node is at 0, which is at equilibrium. Second node is at x equal to lambda over 2. Lambda over 2 means that from adjacent, between adjacent and the node. So that's why we got lambda. So 2 pi divided by 2k, 2 pi divided by 4. So then nodes x equal to lambda equal to 1.57 meter. Therefore, for n-T0 occurs at x equal to lambda over 4 because we take midway. So then, substitute the equation, substitute lambda in here, so we got the value is 0.79 meter. Lambda is 1.58. So note that here, node occurs every 1.57 meter from here if the string is long. Let's try another exercise. Right, a standing wave YT is the total of standing wave is produced by the interference of two identical waves. Identicals means that the amplitude same, the wave constant is k is same, and the omega also same. That is mean that by the identical just the direction is different, which is represented by y1 and y2, moving along a string in opposite direction. That is the difference between these two waves. The only difference is opposite direction. So the amplitude of standing wave is 20 centimeter. Adjacent antenna are 30 centimeter apart. The frequency of the wave is 40 Hz. The frequency here given to find the omega, because in the equation we have omega t and kx, right? So you need to find the omega by using this equation. Okay. Substitute the frequency given in the equation here, 2 pi f. So then compose suitable wave function for this y1 and y2 which may produce standing wave measure. This is total, and the amplitude already given 20 cm. The frequency we can find, and the adjacent antenna here we can find the value of k from here. Okay, refer notes back. Okay, let's try to solve by your own. Try to solve. I already give all hint. Then you just find the k, so substitute in the general equation of wave function y1, what is y1, y2, what is y2. So this is the question asked for. Then y1a sine kx cos omega t. A given already, sine constant, kx, k find from here. Omega is given frequency here, so you can find omega. So a, k and omega is same. The difference is only the direction. So this you can find what is y1 and y2. Then show the equation here. Okay, very that's simple. All for chapter 3. So thank you for listening to me, and have a nice day. If let's say you have any inquiries related to the chapter, you can ask in the medium that given by your lecturers. Thanks again. Bye bye.